Hey everyone, in this video we're going to have some fun with functions. Please don't hate me for saying that. Okay, so in this video you're going to be able to define a function and then interpret what function notation tells us. And you might be saying, why do I even care about functions? Well, functions are things you're probably familiar with. So like a linear function, a linear equation, that's a function. And linear relationships are very important to the world. Anything that grows at a constant rate is linear, such as like in a business, your profit, if you sell for like $5 and you sell one item, that's going to grow to constant rate because every one item is going to be $5. You could talk about parabolas or quadratic functions, and those describe like projectile motion, gravity of a ball, the path of a basketball, et cetera, et cetera. You can talk about exponential functions. And I hope you've heard about exponential functions lately because that's how something like a virus grows rapidly. And we can use math to describe all of those different things that exist in the world. So functions are super important. And if you don't like that explanation, I will say algebra is a function-based class. So you learn about all the different functions. So this is going to be extremely important to your learning. All right, then, what is a function? So I've just listed a few examples, so I'll just jot those down here. It could be a linear function, it could be quadratic function, it could be exponential. These are all examples, not the definition. So a function, more specifically, is a relation or relationship between an input, which in algebra and math, input means, what goes into a function or plug in. Actually, let's not use the word plug in. Let's say an input, which is what goes into the function. Makes sense, input goes in. So it's a relationship between an input and a distinct output. So output means what comes out. Back in the day, you might have seen function machines and you'd like have this cute little thing that you were like, okay, something goes in, something happens here, something comes out, that's a function. And that's what we're talking about here. But getting a little bit more specific because we're talking about algebra. So input into a function is usually x value, and output, or what comes out, is usually a y value. So we're talking about like graphs, tables, equations here, which is what we're going to get to below. Okay, all different kinds of equations and functions, and different ways you can look at them. So we'll focus on what is their equation, what is their table, what is their graph, how do they function in the world. Get it? Function. Okay, cool. These are some examples that I hope you've seen before. So you see like y equals, this is an absolute value. That's what these bars are. Absolute value of x minus 2. This is linear, this is quadratic, square root. You can have all different kinds of functions that describe different things about our world. And we can look at their equations, tables, and graphs. Okay, I'm going to focus on one we've probably seen before. I'm going to ignore this notation here for a moment. And the one I'm going to focus on is y equals 3x plus 1. That is a function because every input has a distinct output. What does that mean, Miss Mancini? Well, I could fill out the table for a function. And the way I would do that is I'd say, I don't know, let's pick some values. When x is 0, what is y? So if x is 0, I'm substituting in here. 3 times 0 is 0, plus 1 is 1. So the point on that line would be 0, 1, or we're looking at the table for the function. I could say, what about when x is 1? Well, 3 times 1 plus 1 is 4. What about when x is negative 2? 3 times negative 2 is negative 6, plus 1 is negative 5. And you could then go and graph these and see what the function looks like visually. So here's the x-axis, here's the y-axis. Okay, when x is 0, y is 1. When x is 1, y is 4. When x is negative 2, 1, 2, 3, 4, 5. And you could see what that function looks like and what the relationship between the input and output is, or again, input is x, output is y. Because input is what you just plugged into the function, output is what you got out. Makes sense. And you could say, okay, that's a linear relationship. 3x plus 1 is a line, right? And that could describe anything that has a constant rate in this world. Okay, so that's how we'll look at functions throughout this class. You might be thinking, like, then isn't every equation I ever looked at a function, or are there some things that are not a function? You will notice that in my definition, I kind of skidded by this, but I said distinct output. Okay, so what that means is the relationship between the input and output has to be unique. So for example, when I plug in 0 for x, oops, going too far. When I plugged in 0 for x, you're only going to get y is 1. Okay, you couldn't also have like x being 0 and y then being -7. That wouldn't be a function because it wouldn't have a distinct y value. It would have two different ones, which doesn't even make sense anyway. So you might be like, when does that ever happen? I'll show you below. Just like when you using a vending machine, I think of that as a function. So if you put in like $1 and then you press F7, you should only get out Skittles. You shouldn't get out Skittles and hot Cheetos, even though that would be awesome. The function wouldn't be working because it has to have one outcome from whatever you put in or your input. Okay, whereas this is not a function, so let me show you why. So you have x equals y squared. I flipped this around on you, and I'm going to plug in something for y and see what happens. So let's say y is 1. Okay, you're going to substitute that in for y to get x. 1 squared is still 1. Okay, now let's say, I don't know, y, I'm going to substitute in is -1. -1 squared means -1 times -1, by the way. -1 times -1 is +1. Okay, I'm going to keep going with a few other examples just so you can see what happens here. Let's say y is 3. Okay, y is 3. 3 squared is 3 times 3, which is 9. Now let's say y is -3. -3 squared is -3 times -3. Okay, so a negative times a negative is positive. And what you will notice is when I plugged in 1, I got out two different values. And when 9, again, I should remind you, x is the input, y is the output. I just kind of flipped around the order here. Okay, so when your input is 1, your output is 1 or -1. When your input is 9, your output is 3 or -3. Or if you look at the graph, when x is 2, right, it's x comma y, your y value is two different things. When x is, did I say 2 or 4? I don't even know. When x is 4, your y value is 2. But when x is 4 here, your y value is -2. So you have two different outputs for the input. This is not a function because does not, and I'm going to write this down so you should too, doesn't have a unique y value for the x value. Okay, or it doesn't have a unique output for each input. Okay. To give you an example outside of like being really mathy right now, I just want to remind you of my vending machine. It's my favorite function example. So what would not be a function is if you pressed F7 and you got Skittles and hot Cheetos. That's not a function. It's not working properly because for F7, you have two outputs when you should really only have Skittles. The function wasn't working. Okay, so that's the part about what the definition of a function is. A function is just a relationship between input and output, in our case, an x and a y, but it has to be unique. And again, I care about that because functions describe everything in our world. And if we can use math to describe them, we can look for patterns and make predictions and all kinds of good things. Okay, part 2 of this, we'll talk about the notation. But if you have any questions, please let me know about part 1.